Hey, Juddlers and Juddle enthusiasts. This is my Hack Day 4 presentation. So, last Hack Day, I was really impressed with Kevin's project. Kevin wrote basically an IRC system in Jut, and it was an instant messaging system that worked, and that's not Juddle's intended use as a data flow language, so it was really interesting to see just how much you could get out of Juddle for other intents. And I attempted to use Juddle as an object-oriented programming language, and there's some distinct advantages and disadvantages to doing object-oriented programming that way. So, firstly, this Hack Days theme is GA, and I don't think any release is complete without a built-in standard library game. You've got classics like Ski Free, TI-84 calculators had games built into them, or that you could download at least. So, I built a game in Juddle, and the game I built is Mastermind, which if you haven't heard of, or it's been over a decade anyways, it is a board game from 1972, and the object of this game is there's two players. One person makes a code. A code consists of 4 digits, and each digit can be one color: red, yellow, green, blue, white, or black. And then the other person attempts to break that code. And you get feedback after every guess based on how close your last guess was to the actual pattern. And you use that feedback to improve your guess and try to do it in as few guesses as possible. So there's two big components to running and playing your own games. The first is just making a new game. And this just generates a game object. You can see I give it call it an event, give it a name game, which is like its class type, and say this is a creation event, and give it a name. And the name is just whatever you specify to make it individual. I figured I can get away with that for user-made games, and it makes sense for users to be able to name games whatever they want them to be. The counterpart to make game is make guess, and this program just takes an existing game that you want to play and parses a guess for it, and tells you how you did. And it's a pretty complicated program with a lot of splits and joins going on, which definitely makes me really think about how splits happen, because they're very difficult to debug stuff inside of them. After making the engine, I went on to make some AI to play some games for me, because it's really kind of cool since a lot of the time when you're making AI, you want to record data about their progress to see how well it performs, how well it learns over time. And Jut is actually a really cool platform for just programming AI in, because all of that data is right there, visible to you as you do it. Like, I'm running the program, and it's like logging all of the data that I would be interested in parsing from it. So this is RandomBot, a reincarnation from when I made some poker bots back in AI class. And all RandomBot does is it just generates a list of all possible solutions to the program, which is 1,296 of, and it then tries them one at a time until it gets the right one. So RandomBot is very inefficient. It doesn't learn. We'll see how long it took. So this is RandomBot just ran, and you can see it's trying all these different combinations. And even though it knows how many got correct and partial, RandomBot isn't actually using that information. So let's scroll to the bottom here. Come on, scroll wheel. 479. So we can see the very last guess it tried, it got all 4 correct. The pattern was white, yellow, and it was guess number 479, which is fairly par for average for Unfortunately,
RandomBot.
I can't torture any of you by having you run through a game of Mastermind on my system. So I'll just do a little demo right now with me playing the game. So for my first guess, I typically just do 2 colors, like black, yellow, for instance. Seems like most algorithms agree that guessing 2 random colors is the correct opening move most of the time. And by most of the time, I mean all of the time. Oh, wow. Alright, this is going to be an easy one, maybe. So 2 exact matches, 1 partial match. So there's exactly 3 in total of black and yellow, and 1 of another. So I'm going to try subbing 1 out for another color. Exact match is 2, partial match is 1. Alright, I'm going to swap one of the blacks and yellows then. Just not quite sure what information that'll give me, but it'll be better than what I know now. Oh, wow, okay. Yeah, so it turns out the one I was missing was red. This is going to be a really quick game. Exact match is 1. One of the blacks is probably an exact match. So I need to switch the yellow, the black, and yellow, the red, and one of the blacks around in a meaningful way. The first one had 2 exact matches, which must have been 1 black and 1 yellow. Which means that the black is the far left black one is probably in the one in the right position. Hard
hard to tell which of the yellows is the right one. So I'm just gonna like rotate the last three over a little bit here. So first guess black, second guess is gonna be red, third guess is gonna be yellow, and my last guess is gonna be black. And this might not get it, but I should be able to get it in one more after this if this doesn't do it. Oh, hey, that was it. Wow, I got really lucky. That's like the first time I've gotten one of these in 3 in a long time. And it looks an awful lot like Germany. But I wanted to make random bot better. So I made less random bot, which is still random, although less random. So what less random bot does is the exact same thing. It generates all 1,296 possible solutions, and it randomizes the order. And it tries them. But what less random bot does that random bot does not do is it learns from the data that it gathers. So every time it's going to think about trying a new point, it won't try that point if it knows that based on the past results, that point is invalid. And I thought this was a really basic thing, like a very like obvious, intuitive, like if you're going to write an AI, of course it should do that sort of thing. And it turns out it helps a lot. Like less random bot's actually better at this game than I am. So that's something. Less random bot did this guess in 5 guesses, and the pattern it finally got it all right. Correct was
So
black,
to wrap
green,
this
red,
discussion
white.
up, I wanted to bring up some features that I'd really like to see in Juddle after having used a lot of Juddle in the past 48 hours. Firstly, it would be really cool to have a way to identify users in Juddle. I had some plans for the game where we would make it interactive with users, so someone could create a code like the original game, and then other users would attempt to solve the code. And you could go back and forth like that, but it's a little bit difficult when you can't identify the user who's playing in Juddle right now. So it'd be really cool to have a way in Juddle to just like grab the name of the current user or something like that, which, I don't know, I can see a lot of uses for it outside of this potentially. So there's that. I would also like to see gadgets take up more space horizontally. The thing with gadgets right now is that they stack vertically, and they take up a lot of your screen space, and it's just one of the issues with the Explorer right now is navigating through programs that have a bunch of gadgets in them, and especially programs that like import programs that have a bunch of gadgets in them. It's just like, it takes up a lot of screen space. It doesn't look very good, and it makes scrolling difficult. So I would really like to see this collapsed gadgets like that.
Now for the final part, we use JUT to process and look at our data. And that's exactly what I wanted to do after building the engine and the AI, was to process on their data. So this is just a really simple board put together, comparing myself with Less Random Bot. I've played 6 games, Less Random Bot has played 29 games, and Less Random Bot, on average, takes about half of a guess less than I do to win a game, and is way more consistent, with a standard deviation below 1 and mine being way out there. And you can tell I cheated on one of these games, and I saw the answer, so I put 1, I got the answer right away. And this time chart just shows how many guesses I took to complete games over time. And it's kind of like, these are when I completed games. Each point on the time chart represents when I completed a game, and how many guesses it took.
That is my Hackday project for Hackday 4. I have an environment set up right now, mastermind.dev.jut.io. I encourage anyone who wants to head over there, log in as Joe, and mess around with it. See the data, play with it yourself, have some fun with the game. Yeah. Have a happy Hack Day.